Okay, welcome to this week's laboratory where we'll be doing a distillation of a mixture of hexane and toluene. I want to go over the glassware and the apparatus that we'll be using this week, but first I want to remind everyone about the safety features of the fume hood. There is a stopper at the side of the fume hood that does not allow the sash to go any further. You can manipulate this to go higher, but please do not. We want to keep this at a maximum sash height as shown here. Preferentially, we want to keep this fume hood as low as possible. This allows more efficient sucking of the air out of the environment. And so I really encourage everyone to, while you're not working inside, to pull the sash down so we don't smell the organic vapors in the laboratory. I would also like to take this time to remind everyone that these fume hoods are used for protection of us in the laboratory, and we want to minimize the amount of chemical usage outside of the fume hood. And so I please recommend or ask everyone to do all experiments that we're using volatile solvents to happen inside the fume hood. I apologize, it is cramped, I know. Alright, on to the experiment this week. You will be working in pairs, and so you'll partner up with a friend, and one of you will do a simple distillation and the other will perform a fractional distillation. After you decide who will do what, you will go to the stock room and you will get a kit and you will request it to either be simple or fractional, depending on what you can decide to do. In this kit, you will find several pieces of glassware. First, you will find a 100 milliliter round bottom flask, a distillation head, a condenser, and a vacuum adapter. Furthermore, you will find several yellow Keck clips, and then two additional pieces of glassware that we won't be using this week, another different type of Claisen adapter, and a separation funnel that we'll be using in the future. Lastly, you will find a thermometer adapter that will go into our distillation apparatus. The other equipment that we'll be using is a stir plate. So for the most part, everyone will be having a plate that only has a stir function. You may be given a stir plate that has a stir as well as a heating element. Please do not use the heating element if you have one on one of these plates. Instead, we are going to use the heat from this cloth heating mantle that is connected to a variac. This will provide the heat, and I'll go over in a few minutes how we set that up. We will also be given in the stockroom a digital thermometer that will be used to monitor the temperature for our distillation. Lastly, for those that are doing the fractional distillation, you will receive two separate pieces of glassware. This is a Vigoro column, and this is called a short path distillation head with Vigoro column. So these will be used for the fractional distillation, and they'll be easily set up simply by attaching these together with the still pot at the bottom and the collection flask on the right side. Today I'm not going to use the fractional distillation, but rather a simple distillation. Okay, we are now ready to set up the experiment for the distillation. Before we begin, I would like for everyone to go and get a pre-weight of their two receiving flasks. You will go to the weighing balance and tare your cork ring, so set that to 0, and then weigh the 50 milliliter round bottom flask, get a pre-weight and record that somewhere in your notebook. And then second, get a pre-weight of the smaller 25 milliliter round bottom flask. And keep this in your notebook for later because we'll need that. Now let's go ahead and measure out the starting distillate. So we are going to use a mixture from this bottle of a 40 to 60 ratio of hexanes to toluene. And the way I'm going to do this is simply in the fume hood, I'm going to measure out 30 milliliters with my graduated cylinder. So go ahead and we're going to get, there's 10 milliliters there. 10,
little bit over. I'm going to estimate how much that was, about 0.2 over, so 10.2. And then I get about 9.8 there. So I have 30 milliliters of solvent that I'm going to distill. I'll set my graduated cylinder aside, and I'm going to give the bottle to someone else so they can measure out their sample. First, I'm going to insert a stir bar into the bottom of that still pot, what we're going to call the still pot. And I'm now ready to secure this onto our heating apparatus. You'll notice that we have a stir plate that only has stir function. If you are provided a plate that has both stir and heat, please only use the stirring function. What we'll be using for heat is this heating mantle with variac. Alright, so I'll cover this in a few minutes. The first thing we want to do is take our still pot and go ahead and insert it into a clamp that's attached to a ring stand. There's two clamps that I'll be using. The first and the bottom one will be used to hold our still pot. What I want to do is lower that still pot and to make a nice contact with this bottom heating mantle, and then I will tighten the screw on the back to maintain a snug fit. Also, when I was clamping this onto the glass, I want to make it tight, but I don't want to crank it down so much that I might risk breaking the flask. Okay? I now have the flask secure, and what we need to do is go forward and assemble the rest of the distillation apparatus. The first thing I will do is take the distillation head, and a good idea here is to go ahead and grease all of the joints. We don't want to heat joints that are not greased because they have a chance to stick together. And so what I'm going to do is take a very, very small amount on the tip of my finger, and I'm going to apply it just at the very top portion of this, what's called a ground glass joint. You'll notice that it's only residing on the very top, maybe 1/4 to 1/3 of the glass joint. And then I'm going to place this into the distill pot and twist. And what you'll notice is that there's a nice film that you can see form between the distillation head and the still pot, suggesting that you have a greased joint. I will then now take the clamp and secure this distillation head. And so tighten in the back, and then I'm going to tighten these guys so that we have a secure connection also in the distillation head. I will then go ahead and grease also the other joint that is going to be coming off of the distillation head, so putting grease on this. And then also on the very bottom of the condenser, I will put a small layer of grease. Okay? Before attaching this to the distillation head, I also want to attach the water connections. The water connections will be coming from the inlet to this condenser will be coming from the wall of your fume hood, and this should go into the very bottom inlet. And so I'm going to insert that, make sure that's nice and snug fit, and then the outlet is a clear hose that goes to the sink on the outside of the fume hood, and so I want to also put that on. Alright, so now I have a greased joint there, I have a greased joint here, and so what I want to sort of do is twist this guy into an arrangement so that I can retwist it back into a comfortable, non-forced direction for this condenser with those hoses going toward the back. I'm going to use a yellow ket clip to connect and secure and maintain a nice connection between the distillation head and that condenser. I then have a final vacuum adapter. This is a vacuum adapter that can be used for what's called a vacuum distillation. We're not doing that today, but this inlet allows the distillation apparatus to be at atmospheric pressure, and so it is going to allow us to heat this without being a closed system. So that's very important. We never want to heat a closed system. So again, there's one last ground joint on the very bottom, and so I'm going to apply a small amount of grease to that connection. On this last, I'm going to twist around one full turn to make sure that grease is fully seated between the two connections, and then lastly use a ket clip finally, I will take that first, the larger 50 milliliter round bottom flask. There is a grease joint here, and so I'm going to now connect that guy. Lastly, give it a few twists and use a keg clip. Okay, we are now about ready to start. I want to turn on the water to this apparatus. So I'll do that now. And we want to, this is very important, we want to turn on this water very, very slowly, and we want to maintain a very slow flow. This is very important because there's a chance that these hoses will jump off if there's too much pressure being pushed through these systems. And so a very slow amount of water we want to be flowing through here. Okay, and so notice that this is going pretty fast with a lot of bubbles. There might be a lot of bubbles in the line, that's unfortunate, but we'll just have to deal with it. All right, lastly, we will take our thermometer, we'll take off the sheath, and there is a thermometer adapter that I will, on the outside, go ahead and secure in place and get a rough estimate to where it should lie. And I'm doing this outside so I'm not having to push too much around on our distillation apparatus. I am then going to, if you need to, you might take a little grease and grease the bottom of this guy. You may not need to. And then I'm going to attach that. All right? The last thing I want to do is make sure that the bottom of the tip of the thermometer is right in line with the arm that's going to the condenser. Notice on our on the handout of where the proper alignment of this thermometer is. Okay, I am now set up. I have proper flow through the condenser. I have the thermometer set up, and I'm ready to begin the distillation. Okay, we are now ready for the distillation. What we want to do is first turn on the magnetic stir, and so I'll have a good disturbance of that still pot to have some good stirrage. And then the second, we're going to turn on the variac that is connected to our heating mantle. And what we want to do is first maybe turn this on to 10, somewhere between 10 and 20% to initialize this heating. And after the first 2 or 3 minutes, you should feel around here to feel for warmth. Okay? If you don't feel warmth and you don't see any disturbance in your still pot, you might want to turn this variac up a little bit. The problem here is that different combinations of heating mantle and variac lead to different percentages needed. Unfortunately, while some of you might find that a 10% variac load is enough to be able to create enough heat on your still pot, some of you might find that you need 80%. So, unfortunately, what you'll need to do is slowly increase the temperature on your variac and to find a temperature or a heating source that provides enough reflux on your still pot. What I'm now going to do is watch, observe my still pot to make sure it's going to become warm. What we're going to start to see is condensation begin to creep up the top of this distill head. And when we start to see distillate begin to approach into our condensation condenser, we want to record the temperature that begins. And so that's going to be our beginning temperature of our distillation. The first signs of reflux. Notice that it has not made it to the distillation head as of yet. Distillate has begun to condense near the thermometer, and you'll notice that thermometer temperature has risen to around almost 60 degrees now. And so what we're doing is waiting for this to begin, and so we want to watch, and now we're just starting to see our first drop. Go ahead and raise or record that initial temperature for this distillation. We are going to be watching that temperature for it to maintain its temperature and then drop slightly. When it begins to drop, what we're going to do is change our receiving flask. Okay, I've been watching this distillation, and unfortunately I did not see the dip that sometimes you see. Sometimes you do see a dip, and sometimes you do not. However, right now the temperature is starting to go up relatively quickly, approaching higher 80 degrees up to 90 degrees. And so what I'm going to do now is quickly switch out the receiving flask to the second receiving flask. And I'm going to take this over and I'm going to get a weight to find out what the weight of fraction 1 that contains mostly hexane. And I'm going to allow this middle fraction to contain, or to continue to collect the middle fractions here until it reaches around 100 degrees C. And then I'm going to reattach this flask. However, before I do that, I'm going to get a weight and I'm going to clean out this flask. So let me do that. Okay, I just went and I weighed my fraction 1. What I want to do now is pour this into a separate Erlenmeyer flask that I'm going to keep separate, and I'm going to make sure that I remember that this is fraction 1. And then I'm going to go and I'm going to try to clean out as much as I can this fraction 1. So I'm going to take some air and hold it under the air nozzle and to get as much of that hexane as we can out. So I want this to be dry. And what I'm also doing is monitoring the thermometer here. So now I'm up to around 94 degrees, and so this is the fraction that is in hexane and toluene. So this is relatively dry, and I'm going to hold this to the side, and this is going to be my fraction 3. If you find that you're doing your experiment and before you know it, fraction 1 has reached 100 degrees, and you didn't have a chance to get the second fraction in there, go ahead and just replace it with the second fraction and collect only 2 fractions. It's not going to be as perfect as the 3 fraction version, but and you'll just have to note that you did not see the dip in temperature, nor did you were able to switch the flask in enough time to get the fractions between the dip and 100 degrees. All right, so I'm at 96 degrees, and so in a minute I'm going to transfer to the original flask to collect fraction 3. Okay, just 1 or 2 minutes after this last video segment, we have hit 100 degrees, and so now I'm ready to finally switch out fraction 2 for that clean original flask, that 50 milliliter flask, okay? So the one that just came off will be fraction 2. So now I have fraction 1 in the Erlenmeyer, fraction 2 in the smaller 25 milliliter round bottom, and then finally I'm going to be collecting the last fraction, which is toluene, that is coming off at around 100 degrees. And so now it's up to around 104 degrees. And so again, I'm measuring that I began collecting at 100 degrees, and make sure to monitor the temperature over which you collect these fractions. Very important going forward. This is going to be the last video. We want to distill not until dryness. What that means is that we always want to see some residual amount of solvent over here on our distillation side. It's very important for peroxides and things like that. Sometimes certain solvents can create an explosion problem. All right, so we're going to watch this, and we only want to have maybe 1 to 2 or 3 milliliters left down in here at the completion of this distillation. So once I have done that and I collect this, I will remove my collection flask, and that will be our fraction 3. Put it somewhere safe, and I will then turn off our variac and our stirrer, and I'll raise the whole apparatus away from our heating mantle, and that will allow it to cool much quicker because this heating mantle maintains heat. So raise the whole apparatus, let it cool, because everything is going to be hot right here. And then at our end, go ahead and clean it. We're going to clean the glass joints with acetone and a paper towel to make sure that you get all those that grease off. Okay, so that should be the distillation. Remember, for those doing the fractional distillation, you will be doing it with the Vigoro column and this other adapter. And so at the bottom will be our still pot, and then our receiving flask will be at the bottom of this short path distillation head. Okay, that's it.